What are AR and VR technologies? AR and VR are two distinct yet related technologies that are transforming how we interact with digital content. Virtual reality, VR. VR creates a completely simulated, computer-generated environment that replaces the user's real-world surroundings. Users typically wear a VR headset that blocks out the physical world and immerses them in a new, virtual space. VR is often used for fully immersive experiences like gaming, virtual training simulations, and cinematic storytelling. Augmented reality, AR, in contrast, overlays digital information, like images, 3D models, or text, onto the real world. Instead of replacing reality, it enhances it. AR is often experienced through a smartphone or tablet camera, but is also being used in smart glasses. Examples include social media filters, the Pokemon Go game, or apps that let you visualize furniture in your room. Who can learn it? The AR and VR industry is a multidisciplinary field. Developers, those with a background in programming, especially in languages like C#, C++, and JavaScript, can build the applications and experiences. Designers, artists and designers who are skilled in 3D modeling, animation, and user experience, UX, design are crucial for creating the visual content for AR and VR worlds. Game developers, since gaming is a major application for both technologies, those with game development experience can easily transition into this field. Anyone with a strong interest, the barrier to entry is lower than ever, with many tutorials and online courses available. A strong interest in creative problem solving and a passion for technology are the most important prerequisites. Prerequisites to learn. While you don't need to be an expert in everything, a foundational understanding of these concepts is highly recommended. Programming language. For VR, C#, Unity, and C++, Unreal Engine, are the most common languages. For AR, JavaScript is widely used, along with C# for Unity. Game engines. Proficiency with a game engine is a must. The most popular are Unity and Unreal Engine, as they provide the tools needed to build interactive 3D environments. 3D skills. Knowledge of 3D modeling and animation is crucial for creating the objects and characters that populate AR and VR experiences. Tools like Blender, Maya, and 3ds Max are commonly used. Spatial computing. An understanding of how to work with 3D space, coordinate systems, and physics is fundamental to creating realistic virtual and augmented environments. Main certifications. While a strong portfolio is often more important than a certification, these credentials can validate your skills and enhance your resume. Unity Certified Professional. Unity is a leading platform for AR, VR development. Earning a Unity certification demonstrates your expertise in using the engine, which is a core skill for most AR, VR developer roles. Meta Spark AR Creator Certification. This certification from Meta focuses specifically on AR development for platforms like Instagram and Facebook. It validates your ability to create augmented reality filters and effects, which is a growing segment of the AR market. Job market and job roles. The job market for AR and VR professionals is experiencing rapid growth, with projections indicating a significant increase in demand for skilled developers, designers, and engineers. Common job roles in the AR, VR field include AR, VR developer, builds applications and experiences using game engines like Unity and Unreal Engine. 3D modeler, artist, creates the visual assets, characters, and environments for AR, VR worlds. UI designer, specializes in designing user interfaces and interactions for immersive, three-dimensional environments. Technical artist, a hybrid role that bridges the gap between artists and developers, helping to optimize visual assets for real-time performance. AR, VR engineer, a more specialized role focused on the underlying technology, such as graphics programming, spatial computing, and hardware integration.